everybody. My name is Ashish. Welcome to my channel. Sorry, it took a while for me to create another video as I was trying to juggle the different things. But now I'm back. So this is my follow-up video from the Hashmap implementation that I did earlier. So if you haven't seen that, you can go to my previous video. The link is up there and take a look at that. So this one will become a natural you know follow up from there. So what I'm going to do is my plan is to convert this hash map implementation to a really generic support generics, because the one that I created, this supports like string key value pairs, and that's limited, right? What we want to do is really support generic hash map. So let's just see what we need to change here, right? So we start by saying, okay, we need to generate support generic. So let's define our key value as the type, and then we use node object. So let's just go change the node object first and then see, okay, I want to change this to key, take the type rather than using the string, and then we can store whatever we want as same types. We just basically carry forward, and then we have to change every place to use the key value that we are specifying. This is our key. um, Actually, if you haven't looked at generics, take a look at it, but the idea here is the type is specified, is passed while creating an object. So this is my value, and I will just say get value. This should fix it. Okay, now node get nodes, we don't need any change here. We want to add a node, we don't need any change here. We would need a change in this, so put will be of type K, value will be of type V, and key value pair, same again, get a key type, and okay, I see. So we'll come back to this here. This is object. So okay, fine. So we have to specify. We have to see how we can use this. Start that key and then equals node.b. Okay, so we have a equal implementation. We have a hash code implementation. Okay, this is good. Now our hash map, right? So here we have to specify the node also should change the type that we have to specify, right? And then we say key is our type. So okay, let's look at this method. So hash, do we really need hash? Because we were using a string key type, so we just generated this. I don't think we need this, so we basically can remove this now. If you don't understand why it was removed, you can ask question and I can explain, but it's you don't need the hash because we're gonna look up the hash from the object itself. So now we have a key value and we get a hash code. So here, since we remove that map, we need to make a change. So we don't use our hash method. We basically say get the hash code from the key, right? And then try to use it. Okay. And here we don't need it. And this would be key type. Okay. Okay, so this looks good. Now we have to, okay, so here we have to change this one too as value. Okay, so this file looks good. Let's go take a look onto our own class. Okay, so this one has, we can return the type as Let's go to the get value method real quick. We are returning v. Okay, so this add is good, and then okay, so the error is gone now. So this is pretty much it, right? So we have now converted this to a generic hash map. Now what we will test it. So this is our existing hello world. This should just work, right? Because we can just say that this particular hash map is storing string and string, right? So this should work. Let's just run it real quick and then see whether the output is same as previous. Hello is world, food is pizza, updated value of food is after salad, good, unknown null. Okay, so now we can use the same class to say I want to store integer keys with values. So what can we do that? So let's say I have integer key and string values, right? And then I can just put map dot put one as abc, map dot put abc dbf, and then we can just put system dot at value of is map dot get and then similarly map dot value of is get 2. And let's just try one that doesn't exist. Value of 3 is what will happen here now. Let's see what happens. Okay, run the program. And it is null. This wasn't there, right? So this is good. Okay, so next thing what we want to see if can we store our own class in this hash map, right? So let's just quickly create one. We call it stock, and it has a ticker and it has a name. So if you are going to store class in the hash map as a key, you want to make sure that it is a immutable class, right? So you want to make sure that your members are final, and then let's just generate the getters, and we can basically make them as final also. And let's just generate a constructor because since it's final, we have to initialize in the constructor. So let's just generate the constructor also. Okay, so our class is good. Now we gonna go and say if we can use this into our Hashmap, right? So we create use our class, and let's say we want to store the price of stocks, right? So we call it prices equal to new, right? And then we say let's just create Microsoft stock, and I can say, oops, we can say Microsoft. The name is Microsoft, right? And let's create another one, IBM renewal stock, and let's call it IBM. Let's store the price of this stocks in our hash map. So we put Microsoft 200, then we put IBM, let's say 50, right? And now we try to get the price, right? So we say price of safety is, and we say prices dot get, and say NSFT, right? That's how we simply look up. Similarly, price of IBM is, and we say prices dot get IBM, right? Now, if you don't have the object, you can also do this way, right? You can say so price of MSFT is, and then you can just create object while you are trying to look up, right? So you can say new stock and say MSFT and say now. Okay, so this is what I'm. Okay, so here we want to match on the ticker, right? We want really match on the ticker, so we haven't specified that, right? So let's go fix that. We basically come in here and we have to override, right? So let's override equals. So we can say, okay. And whenever you override equals, it's always a good practice to override hash code also, right? Just remember that, because you want to make sure that the both are in sync, so that object lookup can happen correctly, right? So you can say override method and say hash code. Now for hash code, we can simply say ticker.hashcode, right? So that should fix it. Now what do we want to do for equal? So we want to first return false, right? That it's not matching. Then we check if instance of stock, then we know we can cast it. So stock source properties stock, and then you can simply say return ticker dot equals resource dot. So now we know that our stock is going to be matched based on ticker, right? Okay, where is this reference? So this fix this. Okay. So here you can say Microsoft. I have a different name than the Microsoft created here, right? So we are storing with that. Let's say if it finds, it should find, right? Let's do one more lookup for the stock that doesn't exist. So we know that. So we say price of, let me switch this price of it is, and you can just say prices of that, right? New stock, and say, so this should not be found, right? Okay, let's try to run our program and see what happens. So okay, price of Microsoft is 200, good. again, and look at that, it found that 200 using, so matched it. So our equals, everything is working ready, and Google is not found, right? So it just worked as we expected. So this is now our hash map with the generics is now very powerful, right? We can store any objects, and again, this is a very simple implementation. It's important to understand the concept. But this is how generally Hashmap works, and hope you learn this data structure from this video. And if you like it, like this video, then go ahead and like the video as well. So and feel free to add a comment if you want me to create another video on any other data structure or any other problem. Otherwise, I'll find the next thing that I learned. I'll create a video on it and then share with you. So hopefully you guys can learn along with me as I learn these things. So till then, till I get the next one, I'll see you soon. So till then, goodbye and thank you for watching. Bye.